Number 1. What correlation exists between anatomy of the digestive tract and feeding habits of fishes? So fish adapt to their food differences by anatomic as well as behavioral means. Thus, there are many differences in the anatomy and physiology of digestion in fish. There is a strong correlation between the anatomical structure of the digestive tract and the feeding habits of the fish. Herbivorous fish that depend on fibrous food such as phytoplankton and microphytes differ anatomically and behaviorally from carnivorous fish that consume meat and other more digestible feeds. Number 2. What are the four types of feeding behavior of fish in their natural habitat? The feeding habits and behavior of fishes refer to the process of the search for and ingestion of food. This also includes the manner and the stimuli for feeding. Fishes can be classified according to their food and diet, which refer to the materials they habitually eat as herbivorous, those that feed exclusively on plant materials; carnivorous, those that feed exclusively on animal matter; omnivores, those that derive their nutrients from both plants and animals; planktivores, those that feed on plankton, the microscopic plant and animal life in the water including bacteria. Fish can be grouped into four main categories according to the type of food which they prefer under natural conditions. These are herbivorous, detritus, feeders, carnivores, and omnivores. Number 3. What are the different parts and functions of the digestive system of fish? So the digestive system of fish includes the mouth. The mouth has a variety of adaptations for capturing, handling, and sorting of food before entry into the stomach. Esophagus. Most fish have short, wide esophagus that serves as a transitional area between the striated muscles of the mouth and the smooth muscles of the gut. In general, the esophagus serves only as a passageway. However, enzyme activity has been detected in the esophagus of some fishes, indicating a more active role of the esophagus in the digestion process in these species. Next is stomach. The stomach has a configuration or shape which is convenient for containing food in the shape in which it is ingested. Food is temporarily stored in the stomach. It is gradually being processed through the other portion of the digestive tract. The size or capacity of the stomach in relation to the body weight varies between species and is usually related to the interval between feedings and to the size of food particles. Next is pylorus. The pylorus is a sphincter that prevents premature movement of the food bolus out of the stomach. Around the pylorus, many fish have outpocketings called pyloric caeca. The role of pyloric caeca in digestion has been widely speculated upon. Histologically, they are very similar to the intestine. Next is intestine. The intestine is primarily an organ for absorbing nutrients into the bloodstream. The larger its internal surface, the greater its absorptive efficiency. And the spiral bulb is one method of increasing its absorption surface. Next is liver. The liver is an important metabolic organ. It aids in digestion by secreting bile, a greenish fluid with strong emulsifying properties. The bile is stored in the full bladder and is composed of a mixture of bile salts. Taurocolate, glycocolate bile acids are derived from metabolisms of cholesterol and degradation products of hemoglobin, bilirubin, and biliverdin. Next is pancreas. As in all vertebrates, the pancreas has two digestive functions. It is the source of exocrine secretion of digestive enzymes, proteases, lipases, and carbohydrates into the intestines, and endocrine secretion of the hormones insulin and glucagon that act to lower and raise blood sugar. Now, letter B, crustaceans. So the crustaceans' digestive tract is mostly straight and consists of the foregut. The foregut begins at the posterior edge of the gills and includes the esophagus, the stomach, and the pylorus. In fish such as the cyprinus, which lack both a stomach and pylorus, the foregut consists of the esophagus and an intestine anterior to the opening of the bile duct. Mindgut. The digestion process actively continues into the intestines after preliminary digestion in the stomach. All fishes have intestines. The length of the intestine varies from as low as 1 to 5 to as high as 20 times the body length. In in general, in some fish, the intestines may be short and straight while it can be long, folded, and looped in others. In general, herbivores have longer intestine than carnivores. Next is hindgut. The hindgut is an extension of the mindgut. Digestion has been shown to continue in the hindgut, although with a gradually diminishing digestive or absorptive function and increased secretion of mucus and the pH neuronutrial. Histological sections show a sudden change from columnar trajectory and absorptive to a squamous epithelium that produces mucus. Number 4. What are the four general configurations or shapes of the fish stomach? There are four general configurations or shape of fish stomach. This includes a straight stomach with an enlarged portion. Next is A, U, or J-shaped stomach. Next is a stomach shaped like a Y on its sides where the stem faces the caudal portion. And number 4 is stomachache in fishes, such in carps and other cyprinids. Number 5. Discuss the relationship between gut length and feeding habits of fishes. Some general statements can be made on gut length in relations to feeding habits of fish. Within the same fish species, the relative gut length can change as feeding habit of the fish changes. Gut length is directly more related to the amount of indigestible material in the food rather than whether the food source is of plant or animal origin. Fish that ingest large amount of detritus have gut lengths similar to those herbivores. Number 6. Differentiate the four types of epithelial cells found in the hepatopancreatic tubule of the crustaceans. Each tubule consists of four cellular types: E. embryonic, F. fibrillar, R. resorptive, and B. blister-like. E cells have embryonic features and some of them were found in mitosis. F, R, and B cells possess in apical brush borders. F cells have central or basal nucleus, a conspicuous RER, and dilated Golgi cisternae. R cells shows a polar organizations of organelles in three areas: apical with numerous mitochondria and sertubules, a central area with the nucleus and the RER, and basal area containing as SER like tubule system and mitochondria. These cells were observed at different stages of their life cycle. In an early differentiation stage, they comprise an apical and cytotic complex and Golgi vesicles. Number 7. Define and explain digestion. So, digestion is the process whereby ingested food nutrients such as proteins, lipids, and complex carbohydrates are broken down into units that are small enough to be absorbed across the gut wall. The process is accomplished through the action of digestive enzymes. The ability of fish to digest food depends on the secretion of adequate quantities of the appropriate types of enzymes. Many of the enzymes are stored in an inactive or coenzyme form. Once secreted into a favorable environment for digestion, usually influenced by pH, these inactive enzymes are converted to the active form ready to perform their specific digestive function. When various nutrients have been adequately digested, they are then absorbed primarily in the midgut. 8. Describe the steps and enzymes involved in protein digestion. So, protein digestion is a proteins are hydrolyzed into amino acids or polypeptide chains of a few amino acids with the help of enzyme known as proteases. The process can occur in acidic or basic pHs. Number 1. Pepsin. Pepsin and hydrochloric acid play important roles in protein digestion in fish stomach. The fish optimum for pepsin about pH 2.0. Pepsin is synthesized in the gastric gland in the inactive form called pepsinogen. Hydrochloric acid converts the inactive pepsinogen to the active pepsin. Pepsin is an endopeptidase and cleaves or cuts most peptide bonds in the interior region, particularly where linkage are formed by aromatic amino acids, phenylalanine, tyrosine, and tryptophan, and acidic amino acids like aspartic and glutamic acid. 2 is trypsin and chymotrypsin. Trypsin and chymotrypsin are involved in the alkaline digestion of proteins These enzymes are synthesized, stored, and secreted in an inactive form by the pancreas and transported to the main gut and pyloric caca. Trypsinogen is activated in the intestine by enterokinase, an enzyme secreted from intestinal mucosa. When an activated trypsinogen becomes S-trypsin, trypsin activates chymotrypsinogen to chymotrypsin. Both trypsin and chymotrypsin are endopeptides but leave different linkage in the protein. Trypsin cleaves peptide linkage which are formed by basic amino acids arginine, lysine, and histidine. Number 3 is carboxypeptidases. Carboxypeptidases are also secreted from the pancreas in the inactive form. These are exopeptidases which cleave in the C-terminal amino acid of peptides or proteins. There are two types of carboxypeptidase, A and B carboxypeptidase. A is active towards proteins with aromatic C-terminal amino acids, while carboxypeptidase B acts preferentially on those peptides with basic amino acids. Number 4. Aminopeptidases. Aminopeptidases are exopeptidases that act on N-terminal peptide of proteins. In summary, because of the complexity of proteins, their complete digestion has to proceed in a number of steps. The protein molecule is first hydrolyzed into relatively large polypeptide fragments by endopeptidases. These fragments are then hydrolyzed by enzymes acting on the amino acids and carboxyl bonds, and finally dipeptidases reduce the protein to its constituent amino acids. Proteins can be absorbed as a whole. Proteins peptides are pre-amino acids. Protein micromolecules may be absorbed in the gut epithelium via pinocytosis. Letter B. Lipid digestion. So lipases hydrolyze ester linkage in triglycerides. The end products of lipase activity are glycerol and fatty acids. Lipases are detected in the pancreas, pyloric caca, pyloric intestine, and liver. In milkfish, lipase has also been detected in the esophagus. Milkfish intestinal and pancreatic lipases appear to have two pH optima, pH 6.8 to 8.0 and pH 6.4 to 8.6 respectively. The detection of two well-defined pH optima, one of slightly acidic and the other at alkaline pH for both the intestinal and pancreatic lipases, suggests a physiological versatility for lipid digestion in milkfish. pH Phospholipases are enzymes that hydrolyze phospholipids. Lipids are taken up by the intestinal and caecal epithelium partly as fatty acids, mostly of monoglycerides, and partly as droplets in transperms, bloods, and lymph vessels. Next, letter C is carbohydrate digestion in fishes and crustaceans. Carbohydrates digest a complex carbohydrates and are found in fish intestines. They are very important in herbivorous fish because of the high levels of carbohydrates in plants. The enzymes amylase catalyzes the digestion of starch. There are two forms: amylase, which acts randomly cleaving the chain from within, and B amylase, which cuts the chain at every 2 glucose units at the branch point. Another enzyme, dextrinase, does the work. The amylase and dextrinase produce maltose. Number 9. Discuss the factors that may affect digestion and absorption in fishes. The efficiency of digestion and absorption is also affected by the condition of the digestive tract, pancreas, and the liver in fishes, or hepatopancreas in crustaceans. Nutritional disease and bacterial infections of the digestive system can diminish the digestive and absorptive function in fishes and crustaceans. Number 10. Explain the different stages in the feeding process in fish. Una is yung appetite and satiations. Appetite is the state that initiate arousal and feeding behavior. Knowledge on the factors that trigger appetite and satiation are very important to fish farmers who want to maximize feed consumption, growth, and conversion efficiencies of their fish stock by adjusting feeding speeds. Appetite which is controlled by the hypothalamus is stimulated by the gut fullness and or other metabolic changes which affect food consumption. Arousal and search. Fish on a fixed feeding schedule can learn to anticipate feeding times, but arousal is often due to Pavlovian conditioning. The sleight of sounds of farm workers about to give feed can stimulate feeding. Next is location and identification. The chemical and physical characteristics of food particles are important to consider so that fish can successfully locate food. Making food more obvious to fish will make them easier to locate in the water column. This can be done by adding chemical attractants, providing color and contrast, maintaining desirable size and shape of particles, and manipulating light intensity and turbidity. Next is capture. Capture in carnivores, small particles can be ingested whole by being sucked into the mouth from a distance. Capture success in the wild depends on prey such and avoidance behavior, but this is not applicable in culture, using a complete on supplementary feed. Next is taste testing. Once the food is captured inside the mouth, the fish or shrimp tastes the food, leaning to swallowing or rejection. Next is swallowing or rejection. Food which tastes good and have optimal practical size, shape, and texture will be swallowed by fish. More rejections and disintegration occur in pellets that are hard, abrasive, and are much longer than their mm, diameter. Large particles are usually ejected through the mouth with a coughing actions. Therefore, feed should have the correct size and texture for the species in question. 11. Name some methods in formulating diets. Give the advantage and disadvantage of each method. There are several methods of formulating feeds. These are Pearson square methods, algebraic equation, trial and error, and linear programming. There are advantages of each method. Pearson's Pearson's square is a simple, quick way to calculate the amount of feed necessary to meet a nutrient requirement of livestock and other animals. This method is most effective when only two feeds are being used. Next is algebraic equation. It helps us to solve the problems more quickly and easily than we could otherwise. Next is trial and error method is generally used for formulations for swine and poultry. This method tries different diets and manipulates it until the nutrient requirements of the animal are met. Next is linear programming. It helps to solve multi-dimensional problems. Linear programming is a mathematical procedure by which limited resources are allocated to selected schedule are evaluated to achieve an optimal solution to a particular objective. And there are the disadvantages of these methods. The Pearson square method does have its weakness. It does not account for vitamins or minerals. And the trial error disadvantage is waste a large quantity to test of materials if you run prolonged tests. In some cases, you may be unable to reuse all test subjects or catalysts, so you have to dispose of the materials. In the linear programming problem, the disadvantage is problem that is concerned with finding the optimal value of the given linear function. The optimal value can be either maximum value or minimal value. Here are the given linear functions considered above. Number 12. Why is it important to know the nutrient content of feedstuff and their levels before one can start formulating? It is very important to know the feeding value and metabolized energy content of feedstuff for balancing animal diets. Feeding value and energy content of animal feeds change according to maturity stage, soil conditions, fertilization, climate, and processing methods, and etc. Number 13. Why is protein the first nutrient to be considered in formulating a diet? Protein is usually the first nutrient considered, with the level of energy in the diet being adjusted to provide the optimum ratio. The protein has to be balanced for essential amino acids. It is the main constituents of the fish body. Animal sources are higher in protein than plant sources. Number 14. Discuss factors to be considered and their importance in formulating a feed for a specific species. The two most important factors to consider in formulating a feed for any aquaculture species are nutrient requirements and feeding behavior. Other factors to consider are the stages in the life cycle, larval growth, or broodstock and the type of culture system. Like any other animal, fish and crustacean needs enough protein, lipid, energy, vitamins, and minerals. Number 15. Give at least 3 feedstuffs that are good sources of a protein. Available feed resources are either of animal, fish meal, meat, and bone meal, or plant origin soybean meal or sunflower meal, cottonseed cake, and ground cake. Neglected or underutilized protein sources include pigeon, peas, cowpeas, and chickpeas. Letter B. Lipids. Lipids are found predominantly in butter, oil, meats, dairy products, and nuts, seeds, and in many processed foods. Letter C. Carbohydrates. But carbohydrate quality is important. Sometimes some carbohydrate foods are better than others. The healthiest sources of carbohydrates are processed or minimally processed whole grains, vegetables, fruits, and beans promotes good health by delivering vitamins, mineral, fiber, and also important phytonutrients. 18. What are the important things to consider in preparation of aquafeeds? Aquafeeds. Aquafeeds refer to any feed given to aquatic farm animals as part of aquaculture. Fish require a balanced mix of essential nutrients such as amino acids and fatty acids and vitamins to thrive, and it is the key component of sustainable aquaculture, using feed ingredients that support sustainable growth of the aquaculture sectors and preserve the unique combination of nutrients needed to sustain a healthy fish and healthy people. There are 5 important things to consider in the preparation of aquafeeds. The option ingredients continue to expand and improve. Number 2, pairing taurine with plant-based proteins unlock their aquafeed potentials. Number 3, trimmings can reduce the need to harvest fish for feeds. 4, sustainable feeds help maintain nutritional balance for healthy fish and healthy people. And number 5, improved feeding methods reduce impacts to the environment. Number 19. Why do we need to process feed and feed ingredients? Because processing is performed in order to improve the digestibility of feedstuff, to extend the shelf of life of product, or to make use of or, to make use of byproducts the human food industry such as wheat milling, soybeans, meals and house, rice bran and beef. Number 20. Why is grinding of ingredients a necessary step in feed preparation? Because the grinding of ingredients generally improves feed digestibility, acceptability, mixing properties, palatability, and decrease the bulk density of some ingredients. It is accomplished by many types of manual and mechanical operation involving impact, attrition, and cutting. 21. Explain the importance of knowing the moisture content of feedstuff and feed, especially prior to storage. Moisture content more than should not be more than 10% and relative humidity not greater than 65%. It is important to knowing this to prevent fungal growth and insect infestation. The grows best 26 to 37 degrees of temperature should not be too high to prevent destruction and reduction of nutrient. 22. What are some typical examples of anti-nutritional factors in feed ingredients and their effect on aquatic animals? How are these factors eliminated or minimized? There are various ways of processing raw materials that can destroy some anti-nutritional factor present in feedstuff. They are soaking, heating, chemical treatment such as extraction with organic solvent and deoling. The kind of treatment will depend on the substances present in the feed ingredients. Different methods of feedstuffs processing: soaking, heating, cooking, dehaling extraction with the organic solvent, and chemical treatment. 23. What is the purpose of pelleting and how does one make floating and sinking feeds? Basically, the purpose of pelleting is to take a finely divided, sometimes dusty, unpalatable, and difficult to handle feed material, and by using heat, moisture, and pressure, form it into larger particles, and it is one of make floating and sinking feeds by the extrusion cooking causes a high level of gelatinization of the starches. 24. Explain briefly the basic step in small-scale feed preparation and compare this to the two-step in commercial feed preparation. Steps in small-scale feed preparation: mixing of locally available feeds ingredients at home is a practical way of producing feeds of shrimps and fishes Number 1, grinding. Dry ingredients are finely ground until the particles or similar size are obtained. Number 2 is screening. The ground ingredients are shipped or sifted using number 40 ships or a nylon net with mesh size of 40 or 125 millimeter. Number 3, weighing. All ingredients are weighed or measured accurately in bowl or basins. Number 4, mixing. All dry ingredients are mixed thoroughly. The vitamins and minerals are mixed separately with the liquid source and added to the dry mixture. The mixture is thoroughly mixed for another 5 minutes. Number 5, gelatinization or cooking. To cook cornstarch, bread flour, and grinders, 1 part starch is added into 4 parts of water. Kneading. Number 6, the gelatinized binder is removed, heat and allowed to cool. The cool gelatinized starch or binder is added to the dry mixture and mixed for 5 minutes until a stiff dough is formed. Number 7, pelleting. The dough is squeezed and passed through a meat grinder. The appropriate die is used for the size of fish or shrimp to be fed for various sizes. Steaming. The pelleted feed is spread evenly on wire nets that fit inside the metal holders of the steamer. Water is boiled 5 to 8 cm deep in a big pot and the pellets are steamed for 5 minutes. Overcooking or steaming can cause lost nutrients and make pellets stick to each other. Number 9, drying and cooling. The steam pellets are air dried for a few minutes with electric fan, transferred to an oven and left overnight for 8 to 12 hours at 50 to 60 degrees Celsius. Number 10, cutting, packaging, and storage. After the pellets are removed from the oven, they are cooled for 30 to 60 minutes. The dried, extruded, or pelleted feeds are cut to the desired lengths, placed in covered plastic jars, and stored in a cool, dry place.